Hello. In this video we're talking about the rational zero theorem. And according to the rational zero theorem, what we know is that if we have some polynomial and all of its coefficients are integers, the numbers that are multiplying by the x's, if those are all integers, so non-fractions, non-decimals, then we can make a list of every possible zero that the function has. And they're always of the fractional or rational form p divided by q, where p is a factor of the constant of the function, what we usually find for the y-intercept, or the number that's typically listed at the end that's not multiplied by a variable at all. And then that would be divided by some q, and q is a factor of the leading coefficient. The leading coefficient is the number multiplied by the term with the highest exponent. So just to kind of talk about what this means for a second, let me look at the quadratic equation here. If we have like 3x squared plus 7x plus 2, this will, and we'll say equals 0, this will factor into 3x plus 1 times x plus 2 equals 0. So it has two factors, or two zeros, negative 1/3 and negative 2. Now if we follow the pattern of what we just talked about, we know that factors of 2, the constant, include 1 and 2, and that's really it. And we need to consider that a positive and negative version for each, so a positive 1 times positive 2, or negative 1 times negative 2. And then the part at the end, the 3, has factors of plus or minus 1, plus or minus 3. Again, 1 times 3, or negative 1 times negative 3. And we can turn these into fractions. And so it's the constant, which is 2, that's going to go on top. So I could have 1 over 1 with the plus or minus 1 over 3, and so I've done the 1 with both of these now, and now the 2. So plus or minus 2 over 1, and plus or minus 2 over 3. And you can see that with our answer of negative 1/3, there it is right there. And with our answer of negative 2, there it is right there. So we had 8 possible zeros that would work here, and we did find the 2 that were actually zeros in this list. So what we want to do in our examples 1 and 2 is create the possible list of zeros for all these functions. And so we look at our constant, the negative 15 first. Things that multiply into 15, 1, 3, 5, and 15. Okay, and again we have to consider both the positive and negative versions of those. If we look at the 2, 2 only has two numbers, a 1 and a 2. Now, to make our list, we take our number from the constant and divide it by the number from the leading coefficient. So I'll start with the 1 and I'll match them up to the 1 and the 2. So plus or minus 1 over 1, plus or minus 1 over 2. Now I'll do the 3, plus or minus 3 over 1, plus or minus 3 over 2. I'll go to the 5 next, plus or minus 5 over 1, plus or minus 5 over 2. And then I'll do the 15, plus or minus 15 over 1, and plus or minus 15 over 2. And so we have a large list. I see 16 different possible numbers here that would work as potential zeros. And so we've narrowed down our list of all real numbers that could work to this list of 16. Let's try number 2. Number 2 has the constant of 16 with plus or minus 1 as a factor, plus or minus 2, plus or minus 4, and plus or minus, I need 8, plus or minus 8, there we go, and plus or minus 16. And then the 6 has possibilities of plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So when I make this list, again, I'll start with the 1, and I'll match it up to all 4 of these. So plus or minus 1 over 1, which is just 1, of course, plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. I'll go to the 2 and match the 2 up. 2 over 1. 2 over 2 we already have because that's the same as 1, so I don't need to list that. But I do need 2 over 3, plus or minus 2/3. And then 2 over 6 is the same as 1/3. We already have that, so I don't need to go there. So let's try the 4. So plus or minus 4 over 1. 4 over 2 we already have because that's the same as 2 over 1. Plus or minus 4/3. And plus or minus 4/6 we already have because that's the same as 2/3. Let's go to the 8. So plus or minus 8 over 1. 8 over 2 we already have, which is 4. 8 over 3 we don't have, so plus or minus 8/3. 8/6 is the same as 4/3. We do already have that. On to the 16. Plus or minus 16 over 1. 16 over 2 is the same as 8. Check. 16 over 3 we don't have. 16 over 6 is the same as 8/3. We do have that. So there's the list of our rational zero possibilities. We have 24 different options here, still considerably less than the infinitely many that we had before. And so if we wanted to find some zeros and we didn't necessarily know where to go, we now have a list of 24 options to try. Okay, we're going to use this and the Descartes rule of signs when we learn that in order to help us find zeros. For now, we are done.